Before we get started today, questions over the homework, because I think there was one, yes? Number 11 or 12? Yes. Because this one, the signs need to be the same. Third term's positive, so the signs are the same and match the sign in the middle term. So that's why it should be negative and negative. So that, I think, will fix that one. So we're going to look at 10 first. So 5x squared minus 18x plus 9. Two sets of parentheses with 3 spaces. Now for this one here, since the third term is positive, our signs are the same and match the sign in the middle term. So negative and negative. All right, guys. So here we go. Factors of the first term, we would have x and x, 5 and 1. There's only one set of factors. Now our factors of 9, the second one, 1 and 9 and 3 and 3. I'll try 3 and 3 first. And if we check this here, 5 times negative 3 would be negative 15x. Negative 3 times x would be negative 3x. And negative 15x minus 3x would be negative 18x. So these are our factors. 5x minus 3 times x minus 3. And that's it. Luckily, all the ones from the second homework assignment are factorable. So that's part of the reason I picked that one out of the backside. Because it does work. Any other questions on the two homework assignments? Where we left off yesterday was with our sum and difference of perfect cubes. We did the first one, finding the perfect cubes. So we'll go on and look at the second problem. X cubed minus 64. Now the first thing we can do in checking to see if this is a difference of perfect cubes is, well, we can take the cubed root of both terms. Because if we can take the cubed root of each term, it means that both of the terms are perfect cubes, and it does help us in solving. Now out of the two of these here, the first one, the cubed root of x to the third, is, well, just x. But we can take the cubed root of 64, which is indeed 4. So that does tell us that we do have two perfect cubes, so we're subtracting them, so it will be our difference. Now we will have two sets of parentheses, bless you. The first set of parentheses will have 3 spots, the second will have 5. The first one's going to have 2 terms and a sign, the second one's going to have 3 terms and 2 signs. Questions on this so far? Our signs are the same. Opposite always end on a positive note. So since we're talking about a difference, the same would mean we start off with minus. Opposite would be plus. Always ended on a positive note. So plus. So for this one here, we have minus, plus, plus. Now we can start filling in our first term, our x. And in our first set of parentheses, the first spot would be x. In the bigger set of parentheses, Our first spot is going to be that term squared, term to the first power, and then we would not list it in the third because it would be to the 0 power, which is just 1, and it would simplify out. Questions on how we plug this first set of terms in? Now we can go through and plug the next set of terms in, our 4. So for the first one, it's just 4. In the bigger one, where we have our x squared, we're not going to list the 4. In the middle one, we really have 4 to the first power, or we can just put it as 4. And in the last spot, it's going to be 4 squared. Questions on how we wrote this here or how we got to this point? Now we just need to simplify. So our first spot is going to be x minus 4. Well, our x squared is just, well, x squared plus 4 times x is 4x, and our 4 squared is 16. So this x cubed minus 64 factors to x minus 4 times x squared plus 4x plus 16. Questions on this here? You ready for the next one? Okay. Next one here, we have 27a to the third plus 64. So again, just like with the last two, we can take the cubed root of 27a cubed and the cubed root of 64. Well, the cubed root of 64 is, well, 4. We just took that a minute ago. Now we can also see if we can take the cubed root of 70 or 27a to the third. It is indeed, because our cubed root of a to the third is, well, a. Our cubed root and that a to the third power would simplify. Now 27, we can do it in the calculator. We can say cubed root of 27 is indeed 3. We can't type the cubed root of 27a to the third into the calculator, at least the 30xs and the TI-84 plus, because it needs a value for a. But it tells us that both of these here are perfect cubes. So we can do our setup again. Too many spaces. And again, I'm going to start off with our signs, because our signs should be the same. Opposite always end on a positive note. So our starting problem was plus, so for it to be the same would be plus. Opposite would be minus. Always ended on a positive note. Plus, minus, plus. Now for our first spots, well, now we're looking at 3a instead of just a single variable. So our first spot would be 3a. Then on our other spot, we would indeed have 4, our second term. Then the first spot in the bigger one would be 3a squared. Then we'd have 3a to the first, or just 3a. And then the last one, we don't really write it, but it would be 3a to the 0. Since that whole term is to the 0 power, would be 1. So we don't have to write that in. So in the middle one, we would have 4 to the first. Last one, we would have 4 squared. We technically do have the 4 with our 3a squared, but it's to the 0 power, which makes it 1, so we don't have to list that one there. Now, even though this one's looking a little bit different than the last ones, our first set of terms is still 3a plus 4. It really doesn't simplify. We don't have to do much to it. Now, our first set of parentheses, or our second set, 3a squared is actually not going to be 3a squared, because we have to square both terms. 9a squared. Yeah, because the way it worked out that way the last few times, because x squared is x squared, because we're just saying x squared, x times x is x squared. It just sounds the exact same. And our 3a times 4 is 12a, and 4 squared is 16. Yeah, it just works out when we just had the variable being squared with and without the parentheses. It sounds the exact same. Here we do have to square the 3a, so 3a times 3a gives us 9a squared. Questions on this here? Well, that's fine. It's okay that it's not a perfect square, because we really need it to be a perfect cube. Now, the cubed root of x to the third would be x. The cubed root of y to the third is y. So if we look at the cubed root of 192, so this is not a perfect cube. So, and we can check to see with 81, and it is not as well. But if we look back at these two here, is there a greatest common factor between 182 or 192 and 81? Because they're both not divisible by 2, but they are both divisible by 3. So we have to divide 192 by 3, which is 64. So we have 64x to the third minus 27y to the third. Okay. (64 and 27). Well, we know the cubed root of 64 is 4, and the cubed root of 27 is 3. Partially because we've done those already. We did those earlier today. Questions on this here so far? So the kind of giveaway that this is a difference or sum of perfect cubes is our x to the third, y to the third. Otherwise, it's not going to factor at all. So we're hoping it is a perfect cube. So we start looking for factors of both terms before we dismiss it completely. Questions on this here? Our signs are the same, opposite, always end on a positive note. So our same would be minus, opposite would be plus, always ended on a positive note would be plus. So we have minus, plus, plus. Our first term for us here is our 4x. And we can go on and fill the second term in that first spot, which would be 3y. Now, even though we do have an x and y term, pattern still stays the same. So in the middle, first one would be 4x squared. In the middle, we would have 4x. Then we wouldn't have 1 in the last spot. 3y would have nothing in the same place as our 4x squared. The middle one would be 3y. And the last one would be 3y squared. Well, finally simplify this down, we would have 3 times our 4x minus 3y. Now we do need to simplify 4x squared. We need to square. 4 squared would be our 16, and then we'd have x squared plus 4x times 3y. Well, here we're squaring it, so 4x times 4x. 4 times 4 would be 16, and our x times x would give us x squared. Yeah, it seems a little weird, especially when it's just x by itself, x squared. Yeah, sometimes it's weird. It looks like the square doesn't go away, but it's actually still there. It's just in a different form. And whenever we just have that one term, because 4x is a single term, we can just square both terms and we're fine. If there was a plus in there or addition or subtraction, 4 plus x, x minus 4, then we have to do distributive properties. Middle term, 4x times 3y. 4 times 3 is 12xy. Then 3y squared would be 9y squared. And that's it. Now, even though we did have 2 variables this time, nothing changed. It's the exact same process, the exact same procedure. It's just now we have variables in both spots. Questions on this here? How do we feel about sum and difference of perfect cubes? We can definitely say for sure when we saw it the first time, this is very daunting. It seemed like it was something that would be very complex in its setup. But once we see how it works, there's not a lot to it. Because once we take the cubed roots, so here, cubed root of x to the third is x. 27 is 3. Same, opposite, always end on a positive note since we have minus, plus, plus. Same, opposite, always end on a positive note. Same, so we have minus, change it, opposite, plus, plus. Our first term is x. Our second term is 3. In the bigger one, we would have our x squared, x to the first, x to the 0. Three to the zeros with x squared, so we don't really list it. Middle term would be 3 to the first, and then we plug in our 3 squared. X minus 3, we'll simplify our x squared. Kind of ironically, it's still x squared. Plus, our x times 3 would be 3x. Our 3 squared is 9. And that's as far as it goes. And it does work out every single time that the quadratic, our x squared plus 3x plus 9, is not factorable. It will never be factorable. So we're done after this step. Questions on this here? We're going to do one more of these before we move on to the last type of factoring, which is factoring by grouping, or I like to call it greatest common factor twice. Now, if we look at this here, cubed root of 125 is 5, and the cubed root of x to the third is x. So same would be minus, opposite would be plus, always end on a positive note would be plus. Yes? So we're going to put our first term in first, right? So it would be it is 5. Because, and I did that on purpose, because our first term was our 125, which cubed root is 5. So our first term in this case would be 5, because they are flipped. Then we would have x, so in our bigger one it would be 5 squared, 5 to the first, and then no 5. First one wouldn't have an x, middle one would have x to the first, and last one's going to have our x squared. So when we simplify this, we're going to have 5 minus x times 25 plus 5x plus x squared. And we can leave it as this here. There's nothing wrong with that. If we wanted to rewrite it so the variables show up first, that's a different color, it is possible to do that, except the first set of parentheses is going to be negative x plus 5. The second set of parentheses is going to be x squared plus 5x plus 25. So the only part of having those first and second term flipped would have been the first set of parentheses where we have the negative. The second set would have been fine either way. But both are correct. You just need to list one. There's not a whole lot of reason to rewrite it if you don't want to. Questions on this here? The last one we're going to do, last type of factoring that we have, is factoring by grouping. And one of the main ways, or kind of one of the giveaways that we're going to probably be factoring by grouping, is that it has 4 terms instead of just 3 or 2. It has 4. And we call it factoring by grouping because we're going to be grouping the terms. And factoring by grouping doesn't just work on polynomials with 4 terms. It works on any set of polynomials with an even amount of terms. And we're going to look at the first 2 terms and last 2 terms. Yeah, so we group them together and factor out a common term. Now the way we group them really doesn't matter, because I could group the second and fourth terms together, first and third, and this would work just as well. But it's easier just grab the first 2 and last 2. Now when we look at the first 2 terms, 2p to the third, 5p squared, is there a like term between the 2? P to the second. So we're going to factor p squared just out of these first 2 terms. It's going to take 2p to the third to be just 2p plus 5. Okay, now we're going to look at the other 2, 6p and 15. They have a common factor of 3, yes? And the 3 would be positive, so we'll say plus 3. And if I factor the 3 out of 6, we're left with 2p. And when we factor the 3 out of 15, we're left with 5. Questions on this here? Okay. So this is called factoring by grouping. I like calling it greatest common factor twice, because we did one set, we pulled out a greatest common factor from those 2, yes? If we look at this here, is there a greatest common factor between these 2 now? They now have 2p plus 5 in common in both, yes? So we will take it out. We'll factor it out. And if I remove the 2p plus 5 from this first term here, all we're left with is p to the second. And if I remove the 2p plus 5 from the second term, all we're left with is our positive 3. That's it. It's greatest common factor twice. And we'll do a few more here. Now, the order in which we take the greatest common factor out, which one we pick, it really doesn't matter which one we do first. Yeah, we do it essentially 3 times because we do it twice in the first step and then once more. But we try to make whatever's inside the parentheses be the same so that we can pull it out of both because it's in common. Yes? Okay. Let's look at another one. 3n cubed minus 4n squared plus 9n plus or minus 12. So again, I would group the first 2 terms and the second 2 set of terms. Now it doesn't matter which one we do first. So if we look at 3n cubed, negative 4n squared, they both have an n squared. And if we take n squared away from 3n cubed, we're left with 3n minus 4 because the n squared factors out completely. Now we move on to the next set, our 9n minus 12. Well, whatever happens, for us to solve this or factor it by grouping, we really need the other set of parentheses to be 3n minus 4. Because if we're not able to do that, we can't factor out again to simplify all the way down. Because the goal with this is to get 2 sets of parentheses. Well, I would say plus. We would indeed have 3. Well, the reason I say plus is because, well, the 9n and 12, 9n minus 12, the signs are already matching up, yes? The one with n is positive, the constant term is still negative, that's what we want. So we're pulling out a positive so the signs don't change. If the signs don't match, then there isn't one. Yeah, it's not factorable. So we good with this step here. Now, 3n minus 4 is in common with both, so we can factor it out. And if we factor it out, we're left with our n squared plus 3. And that's it. Question? Questions on this here? Unfortunately, it can't because of the n to the third n squared are not like terms. We can't actually combine them. 4n squared is, so 12n cubed, 4n squared do have 4n squared in common. Because if we factor the 4 out of our 12, we're left with 3. And when we factor n squared out of n to the third, we're left with n. And what happens when we factor the 4n squared out of 4n squared? It becomes what? 1. Because whenever we're factoring it out, it will never become 0 because we're essentially dividing it out. So 4n squared divided by itself becomes 1. Well, we did plus here because this is plus. So we're doing plus mainly because there's no sign change. Because when we look at what's left, well, we already have a 3n plus 1. We already have what we want, yes? The 3n here is already matching the 3n here. Our plus 1 is still matching the plus 1. There's no sign change. There's nothing we need to do with it. So we say plus. Because when we divide a number by a positive, the sign stays the same. It doesn't change. If we divide it by negative, positive would become negative, negative would become positive, and we would get that there. So we would divide out a negative if the number was right, but their signs were flipped. We needed it to be switched. Now this one's a little interesting because, well, 3n plus 1 didn't have a greatest common factor, but it does match up with the first one, yes? So now we can factor out a times 4n squared plus 1. Because again, when we factor out, we're essentially dividing both of these terms by 3n plus 1 to get that second set of parentheses. And unfortunately, there is no way to divide by something and get 0. The only way that works is if whatever's on top of the division is 0. Yeah. So whenever we factor things out, it'll never have a plus 0. There will always be something there. Questions on this here? So let's look at these here. 224az plus 56ac minus 84yz minus 21yc. So 56a. So we had 224 divided by 56 is 4. Now, I didn't have the graphing calculator pulled up, but I'm going to go on and pull this up. So, there's a lot of things that the graphing calculator can do, and we've seen that over the course of this year, yes? Yeah. Math. So the math button on the graphing calculator. If you notice, the one next to it is number. The ninth one down is GCD. I have to get out of that. Greatest common denominator, greatest common factor. We have this here. Now we can type in 224, comma, 56. And the calculator will actually find the greatest common factor between these two terms. And if we hit enter, it actually tells us it is 56. So it'll do it for us if we need. So between our AZ and AC, well, the common term is A. Now, when we factor 56 out of 224, we divide 224 by 56, we get 4. A factors out completely, but the Z stays. Plus, the 56 factors out completely, the A factors out completely, leaving us with C. Yes? Yes. Now, it feels like we need to go through the process again with 84 and 21, yes? But the problem is already giving us a hint, because for this to work, what's inside this parentheses has to be what? 4Z plus C. Because the only way we can factor this out is if the other set of parentheses is 4Z plus C, yes? Well, this here is what? Negative 21YC, yes? So we would take the 21 out. And Y. Both of them do have Y. And we can look at 84. 84 divided by 21 is 4. So we do have that there, yes? Now, we've said negative a few times, and that's because the 84YZ and the negative 21YC both are negative. So to make them both positive, we have to take that negative out. Questions on this here? Now, problems like this here, it could be that the first two are, you can see the greatest common factor a little bit easier, so do those first. Or it could be that the second set of two, so the 84 and 21, we could see its greatest common factor easier. Whichever one you see easier or quicker, do it first, because then it gives us a roadmap to the other. Now at this point here, we can take out the 4z plus c. And we'll leave it as this here, because so the only thing I was doing there is 56 and 21 are divisible by 7. So what we can do with this here is, realistically, we can factor a 7 out, which would be 8a minus 3y times our 4z plus c. The comma is right above 7. Now, greatest common, really GCD is greatest common denominator. It is the same process with greatest common factor. It works with that there. The graphing calculator can only do 2 numbers at a time, unfortunately. So the ACT will sometimes ask for the greatest common denominator, greatest common factor between like 3 or 4 numbers. Do them 2 at a time, or do 2, and whatever you get, do it and the other number, and keep working it down, and you'll get there. Yep. Either one of these will work for this here. I would take this one. Questions on this here? And that's it.